The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone and welcome to today's webinar. Today we're going to be talking all about uncontrolled pedestrian crossings and particularly strategies for improving safety at these locations. We're going to be focusing on four different countermeasures today: rectangular rapid flashing beacons, pedestrian hybrid beacons, also known as hawks, pedestrian refuge islands, and advanced stop and yield lines. So we'll get into some detail about those countermeasures, talk about how they can be used to improve safety at uncontrolled locations. My name is Dan Jeline. I'm with the Highway Safety Research Center at University of North Carolina at Chapel Hill, and I will be facilitating the webinar today. We are joined today by several panelists. First up is Charlie Zagier. Charlie led the research team from the UNC Highway Safety Research Center that performed a recent study to evaluate the effects of these four countermeasures on pedestrian safety. Charlie has led numerous studies focusing on pedestrian and bicycle safety over the course of his career, and we are very excited to have him here to share the results of this study. Angela Berry is also joining us. She is a traffic safety manager with the Charlotte Department of Transportation, and Angela is going to be sharing some information with us about how Charlotte DOT uses a variety of countermeasures to address pedestrian safety at uncontrolled locations. After the presentations, we're going to be joined by several other panelists for the discussion period. Richard Nassy worked previously for the Tucson Department of Transportation and oversaw the earliest implementation of the pedestrian hybrid beacons, or HAWK pedestrian signals. Michael Frederick of the City of St. Petersburg is also joining us. He's been directly involved with the deployment of the rectangular rapid flashing beacon in St. Petersburg, Florida. We're also joined by Peter Unn and Keith Sinclair from the Federal Highway Administration's Resource Center. They provide training and technical assistance on a range of pedestrian safety countermeasures, including the four countermeasures that we'll be focusing on today. We're thrilled to have all of these panelists here with us today and very much look forward to their presentations and the subsequent discussion. Before we get into all that, though, I want to shift gears for a moment and just talk through a few housekeeping items. Attendees, if you can hear me, I'd like to ask you to please click the hand icon that's located in the upper right-hand corner of your screen. That'll let us know that you can hear us and that we're coming across to you all out there. All right, seeing all those hands going up, great. Thank you all very much for doing that, and thanks for joining us today. If for some reason during the program your computer freezes up, please just reload the website and log back into the program, and you should be able to rejoin the session. We'll be posting presentation slides, and actually have already done that, posted the presentation slides to our webinar archive page. We'll also be posting a recording of this webinar to the PBIC website, so you will be able to look back at anything that you missed today. Again, like I said, the presentation slides are available now. The video archive should be available in a few days. Please note that attendees won't be able to speak during the webinar, so you will have the ability to submit questions and comments using the chat function. You can feel free to ask questions at any time. We encourage you to do that. We'll be holding an extended discussion period, approximately 30 to 40 minutes at the end of the webinar today, to make sure we respond to all of your questions. Later today, you're going to be receiving a follow-up email from the UNC Highway Safety Research Center, which will include a link that will allow you to generate a certificate of attendance. That's very important if you're attending with a group and others are with you. You'll get that email if you register, but you'll need to pass it around to all those other people who attended with you so that they can also get their certificates of attendance. The email is going to contain the link to the website where you'll be able to find the presentation materials from today's webinar, and it's also the place where we're going to be posting the video file, which should be available in a few more days. I'll also mention that the webinar has been submitted to the American Planning Association to be considered for 1.5 CM credits. I'd encourage you to please check the online AICP event calendar for more information about that. You can learn more about all of our webinars that we offer by visiting pedbikeinfo.org/webinars. You can follow the Ped Bike Information Center on Facebook and Twitter to find out some of the latest things we're up to. You can also join our mailing list to kind of keep up to date with information as we post new webinars and schedule new activities. You'll be able to find out about it there. Before we move on to the presentations, I do want to take a quick poll of the audience and ask you all about how many people you're attending the webinar with. This is really important for us to better understand our audience and who's out there. So if you wouldn't mind taking a moment to cast your vote in this poll. Basically, we'd like to hear from you if it's just you out there attending the webinar, if you have 2 or 3 people with you, or if your group is larger, 4 or 5, 6 or 7 or 8 or more. I know there's a few groups out there I heard about that are attending with 20, 30 or more people. So that's great. We love to hear about people doing that. If you could just let us know about how many are attending with you, that'll help us better understand our audience and our numbers out there. So I'll just leave this open for just a couple more seconds, and then we'll move along with our feature presentation. Okay, just a few more seconds to vote in our poll before we move on. All right, thank you all so much. I'm going to close the poll now, and we will get right into the presentations. First up is Charlie Zagier to talk about the recently completed study. So Charlie, feel free to go right ahead.
Okay, thank you, Dan, and thanks everyone for joining us and for other speakers and panel members. So what I'd like to do is talk a little bit about the results of an NCHRP study, National Cooperative Highway Research Program study that was finished about 3 months ago. It's in publication now, should be available early in the calendar year, probably around January, February of 2017. Essentially, the idea was we were to look at what are some of the promising countermeasures out there to help improve pedestrian safety crossing at unsignalized locations. And so we basically needed to narrow down, what are the countermeasures that were promising, and we did this in terms of several steps. Basically, I'm going to cover those in the presentation today. Talk about the overview of the study, the treatment types that we came up with. Dan's already mentioned some of the tasks and how we came up with the results, the effectiveness or the crash modification factor. We're going to talk a little bit about what that is in terms of the overall results, and then how the results of this study may be applied, in other national and local and state guidelines, and how it may translate out into planners, engineers, and other safety professionals out there. Then we have, as Dan said, about 30 to 40 minutes for Q&A. So first of all, I'm not going to read off all these names, but this essentially was our project team. Several of us that time at the Highway Safety Research Center at UNC. We had a couple subcontractors. One was Kittleson Associates, who helped with some of the data collection and the implementation results. And then a couple folks from Broussard and Line who assisted with some of the statistical analysis, and Ron Van Houten, who also was involved with different aspects of the study. So, as Dan said, the idea was that we wanted to narrow down what are some of the most promising countermeasures that we needed to know about their effectiveness in order for agency officials to make better informed decisions on what kind of effect that they might expect from implementing one or different options of countermeasures at pedestrian crossings. So we really did a national search to find out what types of countermeasures were being used by agencies at the local level primarily. And then we also looked at what countermeasures were of most interest agencies, for example, where we did not know their effectiveness already, and which ones tended to be more promising. And it turns out that we ended up with these 14 cities. I'm not going to read them off to you, but essentially these agencies had many of the countermeasures that were of interest. And I'm going to show you our U.S. map. And you can see most of these agencies are kind of concentrated on the East Coast, some sort of in the Illinois area around Chicago, a couple of cities in the Northwest, and some in the Southwest, in Arizona. And someone may say, well, why didn't you get any cities in the middle part of the U.S.? And the simple answer to that is, well, we didn't find really any cities in that major part of the U.S. that had enough of these innovative treatments that we could use in the study, with what we were trying to accomplish. So essentially, we narrowed down the treatments to the 4 that were mentioned before, and I'm going to kind of run through a little bit about what each one is, and forgive me if you all are already familiar with these, but this one, the advanced yield or advanced stop, line, and sign. One on the left would be for states that had we call a yield law that says motorists must yield to pedestrians in crosswalk. We have the kind of the shark's teeth, little triangles, we call it, that are installed about 30 to 50 feet in advance of the marked crosswalk, along with a sign that says yield to pedestrians in crosswalk, versus the states that have what we call the stop law, that says motorists must stop for pedestrians in crosswalk. And again, you can see an example of that with a solid white line in advance of the crosswalk, with the signs that say stop for pedestrians in crosswalk. Okay, the second countermeasure, the pedestrian hybrid beacon, this one many of you have used or familiar with. Essentially, in the 2009 MUTCD, has some similarities to a standard traffic signal with some differences. The signal heads themselves, you see the 2 heads at the top, one at the bottom, overhead and on the right side, that are blank when no pedestrians are around. And then the push button activation on the signal pole that will cause the signal to start with a yellow flash and a steady yellow and go into a steady red with the top signals. And then after a few seconds, it goes to the flashing red, which means motorists, still have to stop if there are pedestrians present, but then they can proceed if there are no pedestrians. And then it goes back to a blank signal. You can see the overhead crosswalk sign, the stop on red sign next to the signal. So it has some differences with the standard traffic signal. And these really developed Richard Nassy and some of the team out in Tucson. And we're lucky to have Richard as one of our panelists. The third countermeasure we wanted to evaluate was the rectangular rapid flash beacon, the RRFB. Mike Frederick and some of his folks down in St. Petersburg area were some of the first to implement that in the city. And basically, it's a yellow beacon between the pedestrian warning sign and then the down arrow, and that this is intended to be a warning device for motorists that need to stop for pedestrians. And it's been used in some other cities around the country, and when it is used, particularly on multi-lane roads like you see here, it's important to have the sign so all motorists can see them coming in both directions, even having the sign on the left side. Especially you have to have it on the right and in the median, but then it's preferred to also have the sign on the left side, just to make sure that all motorists can see them, even if there's a vehicle beside them that's blocking their view of one of the signs. So that's one of the devices we evaluated. And then the fourth one, the pedestrian refuge island, essentially are raised islands. You can see an example here, often used with marked crosswalks. You can see sort of the angled area in the refuge island itself. So pedestrians cross to the median, and in this case sort of veer slightly to the right, and that helps them to be able to see oncoming traffic to their right. And hopefully motorists will stop for them, but if in case they don't, there's kind of a safe or refuge area in the middle of the street for pedestrians. Okay, so let's just kind of run down some of the sample sizes of some of these devices we were able to find. For the advanced yield or advanced stop lines and sign, you can see several cities where most of these were taken: St. Petersburg, Phoenix, Tucson, Portland, some in Cambridge, and a few other cities. Total of a little less than 300 of these, 294. For the pedestrian hybrid beacon, a great majority of these were Tucson, where the device first came into being, and a few in cities like Phoenix and St. Petersburg, and a few other cities. And by the way, let me just mention, there has been some limited amount of research on some of these devices. On the rectangular rapid flash beacon, we had some behavioral evaluations, like on yielding, Ron Van Houten has done, but nothing really in terms of a crash effect. On the pedestrian hybrid beacons, I'll mention, there was a study done by Texas Transportation Institute that did find a substantial reduction in pedestrian crashes from the pedestrian hybrid beacon. But the committee and our team wanted to be able to include sites in more cities to have a wider range of applications of those devices.
Charlie, let me ask a question.
Yeah.
Let me ask a question while you're here. The numbers next to these cities, this doesn't necessarily mean where it says 0 that these cities have none of these treatments. It's just that these were the ones selected for the project in particular.
Yeah, good question, exactly. And in fact, when we went about selecting treatment sites in the 14 cities, we needed to make sure that the devices had been installed several years ago. In other words, so we would have enough after data. But it wouldn't do any good if the device was installed 6 months ago. We wouldn't really have very much after data. So we needed to have several years of after data. And for a before and after study, which we'll talk about later, we also wanted to have the device installed about 5 or 6 years ago, so we could have that number of years of after data plus a few years of before data. So the timing of these devices also was important in determining whether they were chosen or not. And as Dan said, this is not how many devices the city had, but how many we used from that city, in our study. And finally, refuge islands. You can see we did have a fair number of refuge island sites that we found and selected, in all the 14 cities. And there has been some limited amount of research on the safety effects of refuge islands, but it hasn't really been very recent, and it hasn't been, with enough clarity or certainty to really use that as a CMF. So we did pick refuge islands as one of our 4 treatments. So if you kind of look at the sum of a number of cities on the left and how many treatment sites, and also for any kind of research analysis, it's important that you have enough what we call comparison sites or control sites. And this is selecting in each of the cities similar sites as the treatment sites, but sites that don't have any of the 4 treatments. So that way we can kind of do some comparative analysis on the crashes at the treatment sites compared to the comparison sites.
What would some of the similarities be in terms of variables you look at, Charlie?
Well, one of the main things, we're going to talk about site characteristics, but for example, if we pick 2 or 3 treatment sites along a 4-lane corridor, we want to pick sites nearby that are similar to those treatment sites along that same corridor, with the same number of lanes, the same traffic volume, but just didn't have that particular treatment. Okay, now this slide kind of illustrates the types of site combinations, treatment combinations that we used in the study. The first sort of grouping there, again, the AS is the advanced stop and yield sites, pedestrian hybrid beacons, the PHB, the RRFB, and the raised island. And you can see that we did have a certain number, particularly of the raised islands and advanced stop, where that was the only treatment. And maybe there was a marked crosswalk there, but there wasn't one of the other 3 treatments. You can see there's very few of the pedestrian hybrid beacon and RRFBs where that was the only treatment. And the reason is because typically when those 2 treatments are used, they're used in combination with either advanced stop or yield or raised islands, and not just the device itself. And you can see the second grouping in the gray. We had about 146 sites were a combination of 2 treatments, like 57 sites that had the advanced stop plus the pedestrian hybrid beacon, 59 sites with the advanced stop and the raised island. So there were those numbers of combinations. And then 54 of the sites had 3 treatments, particularly the RFB and the pedestrian hybrid beacon. Those are typically used nowadays with the advanced stopper yield and often with a race island. And so you can see that was sort of the more common application of those two devices. And if you sort of look at how many we had in this graph, you can see we had close to 300 sites each of the advanced stop yield and also of the refuge island. We were only able to find around 100 of the pedestrian hybrid beacon again, that were installed with several years of after data. Again, we didn't want to pick a site that only had a few months or even a year or two of after data. And we were even having more trouble finding RRFBs that were installed within that time frame. So we were a little nervous about whether we would have enough sites there to be able to develop a good crash effect. So this slide just basically summarizes that after we identified and selected our sites, we needed to go and collect the proper types of data, not only traffic volume and pedestrian exposure, but also the site characteristics, like was it an intersection or mid-block, was it a multi-lane road, was it 2-lane or 5-lane or 4-lane, what was the area type where the treatment site was, what was the crosswalk type, things like that. And so we did use Google Earth, and we were able to use some of the historic files to go back generally about 10 years. So that way we could see whether a site had maybe changed the type of crosswalk or installed certain warning signs or even changed the treatment within the last 10 years. That was important because for each of the sites, we needed to get between 3 and 4 years and up to 10 years of crash data. So we needed to make sure that we knew what the treatment was during that whole period in our analysis. And so then we compiled the data in a database and prepared it for 2 different kinds of analysis we're going to talk about here in just a second. But first of all, I wanted to tell you a little bit about the characteristics of the sites that we chose. This is sort of a graph of the crosswalk types, and you can see, let's look first at the blue areas, and those are the treatment sites. You can see most of those, the highest levels are where it says E or H. If you look over to the right, that most of your treatment sites had either a ladder type, an E-type crosswalk, or a continental style. We're going to tell you what that is in just a minute. You can see the bars in red. Those were the comparison sites, the untreated sites. Majority of those were an A, which means there was no crosswalk markings. And we did have a fair number of comparison sites that did have some other type of crosswalk, either an E, ladder, or you can see an H, continental style, or a few of the others. You can see a few of the K or the brick or some other type of device. So that gives you sort of an idea of the crosswalk types. And as you see in the upper left, the standard or parallel line crosswalks, we had a fair number of those, but there were more of the continental style you see in the middle there, the sort of the bars across the street, or the ladder type. And you can see in the upper right sort of what that looks like in the real world. Some of the ones on the lower photo is where they position the bars in the continental style to where the tires of the vehicles didn't normally run over them, so they would last longer. Some of the maintenance benefits there. Now, in terms of our sample size for number of lanes, we wanted to really select as many sites on multi-lane, 4- and 5-lane roads in particular as possible for a couple reasons. Number one, because that's where many of the RRFBs and pedestrian hybrid beacons actually were installed in the real world. But the other reason is that most agencies that are having pedestrian crossing problems, in terms of crash problems in particular, these tend to occur on the multi-lane roads. Multi-lane roads with fairly high traffic speeds or volumes. And so we wanted to really get a better handle on how these multi-lane, high-speed, high-volume roadways were affected by some of the treatments, because these are really the types of roads of interest. On the 2-lane, low-volume, low-speed roads, you really don't need these expensive treatments. That typically just a marked crosswalk is good enough, or even an unmarked crosswalk is fine. particularly when the speeds and volumes of traffic are low. But on the multi-lane roads, we really selected a great majority of our sample, as you see here, treatment and comparison sites. In terms of the site breakdown, how many were at intersection versus mid-block, you can see about 2/3 of the treatment sites were at intersection, and about 3/4 of your comparison sites were at intersection. So that, as you might expect, there aren't that many of the treatments actually installed at mid-block crossings as you would be expected at intersections. And roughly half of our comparison sites and about 40% of our treatment sites were along transit routes. And we really went about trying to identify transit routes and transit corridors in each of our 14 cities right off the bat, because we know these are routes that you often have fairly heavy volumes of pedestrians who are crossing to and from the bus stop, and there's a particular need to make sure that we really accommodate safe crossings for pedestrians to get to and from bus stops. And I'll say just a word or two about pedestrian volume. Obviously, we needed to know the pedestrian volume at each of our treatment comparison sites, because this is one of the factors that really comes into play as being related to crash and the potential for pedestrian crashes. Only about 10% of our sites had actual pedestrian counts collected by the city. I think St. Petersburg and Charlotte were the only two where we got some pedestrian counts from the city. The rest we had to actually go out, and we used Kittleson and some of their team, a subcontractor, to go out and do 1 or 2 hour counts at each of our sites. And then we were able to develop some expansion factors to take those short-term counts and expand them to estimated pedestrian average daily traffic or average daily pedestrian crossings. So that was a fairly expensive and detailed process, but essentially we were able to get an estimate of pedestrian exposure at each one of our sites to using the analysis, and we collected all the other factors, the number of lanes and the type of area and the type of crosswalk, et cetera, and built the database. And here, this chart kind of illustrates that we had to get the crash data mostly from the state DOTs in those 14 cities, and we generally able to get crash data from anywhere from about 4 years up to about 8 or 10 years per site. And most of that crash data was gathered, in late 2014. So after we had the database, we went about trying to determine how do we come up with this relationship between the treatments that were installed, these 4 treatments, and what are the crash effects, the crash modification factors. And we wanted to be able to, if we could, to get this information as a function of, whether it's a mid-block or intersection. What about, are some of these treatments more effective or less effective on 5-lane versus 3-lane, or on high volume versus lower volume? So we tried to build a database that would allow us to try to answer these kinds of questions, in addition to try to quantify the crash effect, or the CMF. So first, let's have just a little background on what is the CMF that we're talking about. And essentially, the crash modification factor is sort of a measure of the effectiveness of a different countermeasure, where if the CMF is less than 1, that means the expected crashes after the countermeasure is going to be expected to be less than before. So you want to have the lowest CMF possible for the countermeasure to be most effective. Whereas if the CMF is greater than 1, you've got a problem. That means that there's an increased number of crashes, or increased rate of crashes after the countermeasure is installed. So generally, we were hoping, or we were wanting to end up with finding out which of these countermeasures had CMFs as low as possible. And so just to illustrate this fact, if you look at the values on A, B, and C, question for you is, all right, so which of these CMFs would indicate an expected crash reduction of 25%? And if you guess C, that's the right answer. And so likewise, in the next slide, if we ask the question, if a treatment with a CMF of 1.25 were applied at a given site, how would the crashes at the site change? And as you might expect, that would be an increase of 25%. So that's sort of what a CMF means. Now, in order to get to a CMF, there's really two basic approaches in the research world in coming and arriving at a CMF. One is what we call a before and after study, and it's really more than that. It's really a much better statistical analysis of looking at crashes before and after, conducting what we call an empirical Bayes analysis or some other kind of analysis to really take into account what's going on at the comparison sites, whereas a cross-sectional study, that's more modeling, crashes, modeling pedestrian crashes as a function of one or more of the countermeasures and one or more of the other site characteristics. So almost every research study that you see, safety study, will have either one of these types of studies or the other. Well, it so happens that we are fortunate enough to be able to have the kind of data to use both kinds of analysis. Now, in saying that each of these analysis types has its own pros and cons. In terms of the before and after method, just one of the advantages of that is that you're really looking at actual crashes, at those sites before and after the treatment was installed. And you have basic information on things like traffic volume, but one of the disadvantages and one of the problems is you typically do not know the pedestrian exposure before the treatment was installed. Because remember I told you we went out and had to collect pedestrian exposure at all the treatment sites. Well, that means by definition that the treatment was already there, and we didn't have a time machine to be able to go back and see what the pedestrian exposure was before. Now, in many cases that doesn't really matter, but if a treatment caused more pedestrians to cross because of the treatment, then you may have to wonder, well, are we really getting an accurate estimate of pedestrian exposure by just looking at the after exposure? So that's one limitation of the before and after method. Another limitation of before and after is you can't always find enough sites. Oftentimes you need dozens or even hundreds of sites at some kinds of locations because of relatively low numbers of pedestrian crashes at a site. Most sites in our study had 0 pedestrian crashes. So you really do need to have a fairly substantial number of sites. Oftentimes you don't have enough before and after sites because you need to get, remember, that 3 to 5 years of before data plus the 3 to 5 years of after data, which means you have to find sites that were installed with the treatment somewhere in the middle of that period. So those are some limitations of that method. With the cross-sectional method, one of the advantages is you really don't need that before pedestrian exposure, that you have the data that I talked about before, and you're able to develop a model or a predictive equation that's got more than just the countermeasure in it. It's got things like traffic volume and pedestrian volume, number of lanes. So, and you can often get more sites to conduct an analysis like that. The disadvantage of this type of analysis, it's not considered by most statisticians to be quite as good as a before and after with empirical Bayes, but it certainly has some strengths of its own. And we were able to actually collect enough data at enough sites to use both methodologies. So, okay, so if we have a drum roll, then we know what's the answer. And the answer is we are actually able to develop CMFs for all 4 of these treatments. And so if you look down the list, you can see the treatment type on the left, the CMF in the middle, and did we arrive at that CMF from one of the studies or both studies or just one or the other? And you can see we actually use both analysis types in arriving at 3 of the CMFs, and just the cross-sectional analysis for the CMF for the RRFB. So if you look at those CMFs, if I ask you the question, well, which one from this list would have the greatest effectiveness on reducing pedestrian crashes? And hopefully most of you are answering the pedestrian hybrid beacon, because remember, the lower the CMF, the more effective it is. This CMF there is 0.45, which means a little more than half of the pedestrian crashes would be expected to be reduced in the after period compared to the before period. And next would be close behind is the RRFB at 0.53, so which corresponds to about a 47% reduction in pedestrian crashes. Next would be the Refuge Islands, 0.68, and the advanced software yield with a CMF of 0.75, or about 25% reduction in pedestrian crashes from installing this treatment. Now, as you recall, I did tell you that that we did have treatment combinations. So whenever I mention a PHB or an RRFB, that's any site that had one of those treatments. And it may have had one of the other supplemental treatments too. For Refuge Island or Advanced Yield, we did not include sites there that had a PHB or an RRFB, just to let you know. So if you look real quick, one just a comparison, you notice we had a PHB or a hawk signal that had a CMF of 0.45, and that's not too far different from the result from the TTI study, Texas Transportation Institute study, that found about that same level of CMF, slightly better. And so essentially, you know, these are results that we have for the first time in terms of CMFs for RRFBs and advanced yield and stop lines in particular, and really the first good CMF for Refuge Islands. And the CMF for pedestrian hybrid beacon pretty much is in agreement with the previous study that I referred to. So what does this mean in terms of application of these results into some of the national and other guidelines? We came up with sort of a plan on how to incorporate these results in the next version of the Highway Safety Manual, and certainly this study will be reviewed and included in the Federal Highway CMF Clearinghouse. I don't know if you know what that is, but it is sort of an online resource that has had safety experts critically review hundreds and hundreds of safety research studies on not just pedestrian crashes, but all kinds of roadway safety. And so it sort of comes up with a rating on how good the study was and what the results were in terms of the CMF. So these results will be included with the CMF Clearinghouse. Also, there's a FHWA Proven Safety Countermeasures website. We hope that'll be included there. And the next version of NCHRP 600 on human factors guidelines for road systems, and certainly making use of the results in the METCD and for other guidelines, the state and local level. This slide here kind of indicates that state and local agencies may want to make use of these results, incorporate them into their own guidance and design documents even. And we also think these results are really good when combined with some of the earlier research that we did for Federal Highway on the safety effects of marked versus unmarked crosswalks, where that study essentially found that it's not good to just install marked crosswalks alone when you have multi-lane roads combined with a traffic volume of 12,000 or more. So the question from that study is, well, but what would be effective on those higher volume multi-lane conditions? And so this NCHRP 17-56, we think, really helped to answer that question. That here are 4 different treatments that certainly could be alternatives to improving pedestrian safety on those multi-lane high-volume roads, at bus stops, or where pedestrians are having trouble crossing because of the high vehicle speeds or volumes. So anyway,
we'll cut that slide. Leave that one for later. That wraps up Charlie's presentation. Charlie, thank you very much for giving us an overview of that. It really, I think, gives us an interesting look into how a study like this is done and what are all the considerations. And clearly, a lot of effort goes into pulling the data, analyzing it, and really coming up with a really reliable measure of safety effectiveness. So we've got a lot of questions about that, and we certainly will circle back to Charlie during the panel discussion. But before we do that, I want to turn things over to Angela Berry. So we just heard a member of a research team talk about the ins and outs of that process, but really I think we can contrast that with, as an agency, what do you do to put these things on the ground? What do you decide goes where? How do you treat different locations? And so Angela Berry is going to join us to talk about that. So Angela, I see your screen. Whenever you're ready to go, please go right ahead.
Okay, thanks, Dan. Happy to be here today. Thank you very much for asking the City of Charlotte to participate in this webinar. I really appreciate the opportunity. I'm just going to jump right into things here. Basically, we apply these measures through something we call the Pedestrian Crossing Committee. Let me get that off my screen there. And we field a variety of requests that come to this committee. The committee is managed or co-chaired by myself as the traffic safety manager, as well as our pedestrian program manager, Scott Curry. And like I said, we field a variety of requests. We can get requests from as high as the mayor's office to an observation from a staff member out in the field. Citizen requests come into both Scott and I all the time, and we have some criteria by which we take things forward to this committee. This committee is made up of several different divisions within the department. Contains approximately 25 people that meet on a monthly basis. And then from that, we form what we call investigative subcommittees, and I'm going to talk a little bit about those in just a minute as well. Basically, this group is structured to carry out a document, and I'm glad Charlie ended where he did, an internal document called the Pedestrian Crossing Guidelines, which we are currently updating. So we will be taking a look definitely at Charlie's research and considering that as we update that internal document to the City of Charlotte. So to get onto this Pedestrian Crossing Committee agenda on a monthly basis, there's a couple of different ways you can get onto this agenda. First, if your request falls in one of these 5 areas, what we call a center, our central business district, a pedestrian overlay district, transit station area, or a main street, you automatically qualify for evaluation by the Pedestrian Crossing Committee. And just to give you an example of what that is, I pulled up a tool that we have called Virtual Charlotte and just took a screenshot, and it shows the a transit station area in that light green, sort of to the bottom left underneath the number 74, and then those bright blue areas are pedestrian overlay districts within our city. So if a request were to come in to Scott and myself or anyone really within the city organization and it automatically fell into one of those areas, it would automatically qualify for consideration by the Pedestrian Crossing Committee. And then one other way, if you don't meet those 5 automatic criteria, one other way that you can get on the agenda is if you satisfy the following 3 criteria, and you have to satisfy all 3. First is that your vehicle volumes are greater than 5,000 vehicles per day, and if they're less than that, we actually consider that there's not sufficient conflict to formalize a pedestrian crossing. Vehicle speeds cannot be greater than 45 miles per hour. If speeds on the roadway are greater than that, then we consider only a traffic signal or a pedestrian hybrid beacon as a treatment option. And then the last criteria is that the location is more than 600 feet from another established crossing opportunity. So as most cities have this challenge, especially as their urban core expands, you know, we have signals that can be up to a mile apart. And so an established crossing opportunity for a pedestrian could be literally a mile away. And so we try to take that into consideration as well. Last opportunity, there is one last opportunity for consideration, and that is if more than 20 pedestrians cross in a location in a 24-hour period, we will consider it under the Pedestrian Crossing Committee. So if none of those criteria are satisfied, then we deny investigating it and recommending any subsequent treatment. So I told you I was going to talk a little bit about what an investigative subcommittee does. It's 3 to 4 volunteers from the overall committee, and we get a mix of engineers, planners, and our public service investigation staff, try to mix it up for each subcommittee. They have a responsibility to go out and visit the site. They may request a turning movement count. They may also request a manual pedestrian count, and we've gotten a little creative in doing this as most municipalities struggle with manpower. It's very difficult to send someone out to just sit and count pedestrians for an extended period of time. So we actually have taken to using employees that are on extended light duty and would otherwise be looking for something to keep them occupied. So we use light duty employees to go out, and we get a much better observation of what the traffic looks like during the daytime period, as well as a count, and just a better insight into whether there are decent crossing opportunities for pedestrians or not. We also make sure we look at sight distance, and then that small group, that investigative subcommittee, discusses their observations, comes up with a recommended treatment or treatments, and is responsible for reporting back to the Pedestrian Crossing Committee at the next meeting, or sometimes it takes a couple meetings to get everybody together. So following that, then I'm going to talk a little bit about how we make those selections. Charlie specifically wanted me to talk about what our rules of thumb were for how we make those selections. And we do have a few other treatments that we consider aside from the ones Charlie spoke about, such as just a standalone marked crosswalk. However, I'm going to stick with examples that focus only on the treatments that Charlie has talked about earlier as a result of the study. I'm really excited about Charlie's study. Up until now, we did not have CMFs to apply to these treatments, and so this will help us in making decisions moving forward. Previously, we really relied upon those subcommittees and engineering judgment. Location considerations were very important, and the PED hybrid beacon warrant in the MUTCD was very important for us to consider as well, especially on state roads. Typically, we take an incremental approach, so we try to start with the most cost-effective option and move up from there, but sometimes conditions automatically leap you into that full-blown pedestrian hybrid beacon with an advanced stop condition. So a few Refuge Island examples. This is on Alexander Street here in Charlotte. The location was chosen due to the volume of the street, even though it was just a 3-lane cross-section, 2 lanes in each, or 1 lane in each direction with a 2-way left turn lane. It does carry 7,300 vehicles per day. The distance to another crossing opportunity was fairly significant, and the speeds were less than 45 miles per hour. So this, to us, especially with the 2-way left turn lane, definitely calls for a raised island to be the preferred option, given that we had some pedestrians crossing, but not an incredibly high volume of pedestrians crossing. Next is a refuge island on Tyvola, which is a major thoroughfare for us. It's a 5-lane cross-section, 2 lanes in each direction with a 2-way left turn lane. We chose a refuge island here because of the transit stops. Again, that real estate being available at the 2-way left turn lane makes the refuge island very desirable for us, and definitely an incremental approach. If we start to see the transit stops pedestrian level pick up, we may consider the addition of a pedestrian hybrid beacon at this type of location. And then I believe my last refuge island example is on East Boulevard. We actually did a road conversion from a 4-lane cross-section to a 3-lane cross-section with bike lanes. This is a case where we have a pedestrian island marked with a marked crosswalk, and this is one of those that falls in that pedestrian corridor or pedestrian overlay district. It's very heavily used pedestrian corridor. And then one more refuge island on South Boulevard. Again, a 4-lane, 5-lane cross-section. Real estate available in that 2-way left turn lane to construct the refuge island and provide that pedestrian with the opportunity to make a 2-stage crossing. And again, this is another one of those very heavily used pedestrian corridors. Now moving on to pedestrian hybrid beacon examples. This is Pineville Matthews Road in South Charlotte, 5-lane cross-section, very heavy volumes, and not a terribly bad distance between crossing opportunities, probably on the order of a 1/4 mile. However, this location is directly, the high school is directly across the street from McDonald's, as well as other retail and eating facilities. And we actually had a pedestrian cross, a child from the high school cross and be killed in this location. So chose to go with multiple treatment options to encourage them to make safer crossings, both the raised island as well as the pedestrian hybrid beacon and the marked crosswalk. And then this one is an interesting one up in the university area at UNC Charlotte. University City Boulevard is a 6-lane cross-section with an incredibly wide median. So this is a 2-stage pedestrian hybrid beacon where they operate each leg of the hybrid beacon independent of the other, which provides us with better coordination opportunity with the signals upstream and downstream of the pedestrian hybrid beacon. This actually met the pedestrian hybrid beacon warrants for pedestrian volume versus traffic volume. And then Beatties Ford Road, this is one of our earliest pedestrian hybrid beacons that we installed. Heavily used pair of transit stops resulted in us deciding to put this pedestrian hybrid beacon in this location. What makes this one unique is that we actually signalize, this is one of the ones that is closest to an intersection for us. We haven't experimented with installing them directly at an intersection yet, although we have a few of those coming up. So if you'll notice in this picture, we actually have a supplemental head facing the side street Hildebrand to just help that side street traffic know that they're making a turn towards a pedestrian hybrid beacon. And then the last treatment option that I was going to talk about is the rectangular rapid flashing beacon, of which we have not installed any yet. We do have 4 planned at this time. The first is on a state-maintained road, 7th Street outbound from Charlotte. And the reason that we're going with a rectangular rapid flashing beacon in this location versus a pedestrian hybrid beacon is that this is a reversible lane street. So based on time of day, you can have 2 outbound lanes or 2 inbound lanes. And we actually did count pedestrians. We don't quite meet the warrants for pedestrian hybrid beacon. However, we were able to do what we call a gap analysis to show the state that there were not significant gaps to cross all 3 lanes in one crossing. And so they're open to the idea of us installing rectangular rapid flashing beacon here. Another location is on Kings Drive. This is a 5-lane cross-section and doesn't meet the threshold for a pedestrian hybrid beacon. But observations here show a significant delay for pedestrians to be able to even cross to the Refuge Island. It does connect neighborhoods to a major greenway system, and so we are hoping the rectangular rapid flashing beacon will provide that indication to the motorist to allow we'll mark a crosswalk in conjunction with the RRFB and provide a little more indication to the motorists that they need to be slowing down and watching out for pedestrians in this location. And then my last example for a planned rectangular rapid flashing beacon location is at IBM Drive and Compatible Way. Not a bad cross-section except at this intersection where we have multiple turning movements. And what we've observed is very poor driver yielding behavior during the PM peak. During the PM peak, we've counted up to 120 pedestrian crossings from the right side of your screen to the left side of your screen. And so we're choosing rectangular rapid flashing beacons in this location due to the turning movements and the fact that there's driveways into a major work facility as well as an apartment facility right here. So that's all I have for examples. There's my contact information. And again, I just want to thank HSRC for asking us to participate. We're really excited to be a part of this webinar.
Great, thanks. I will put the screen back on. I'll switch it back to me, but there were a few questions that I might want to see if you can answer while your slides are still up, and those have to do
I'd be happy to.
Those have to do with the, you have several pictures of some of your Refuge Island treatments that don't feature marked crosswalks. And can you tell us a little bit about your thinking behind those? Were those new refuges that didn't yet have the markings, or do you do a lot of those without the markings and can explain why you do or don't put them there?
So we do choose to do them without the marked crosswalks frequently. I think you were probably looking at Tyvola. That one at Kings Drive was another one. Those multi-lane ones are the ones where we generally don't mark a crosswalk at a refuge island without some supplemental device to indicate that drivers need to either be watching for pedestrians or yielding to pedestrians. We don't want to give the pedestrian that false sense of security for stepping out into a crosswalk, and also the multiple threat issue with multi-lanes and multi-lane crosswalks. You know, if the driver in the curb lane were to stop, let's say, or yield to the person in the crosswalk, the second driver in the median lane might not see them and might not stop. We have not yet jumped to the advanced yield signs or the advanced yield bars that Charlie studied in his research. So we're talking about that internally now, whether that should really apply or not, whether we need to consider those. Hopefully that answered that person's question.
I think so, yeah. And so and in some of these cases, I think you mentioned there may be candidates for further enhancement, like the marked crosswalk, maybe the PHB or the RRFB down the line, but it's sort of a more incremental approach to go ahead and get the island there and then provide maybe the full treatments later when you're more comfortable, instead of just putting down the paint, you're saying?
We try to do that incremental approach just to see if, you know, what's the most cost-effective way to help a pedestrian get across the road safely. And sometimes that refuge island is really all you need to give them the opportunity to be able to make those judgments, to judge gaps in only one direction at a time, get out to the refuge island, be able to stage there, and then judge those gaps in the next direction without having to go to that full pedestrian hybrid beacon treatment. As you know, once you start getting into signalization, you start getting into potential real estate acquisition, utility coordination. Not that we're not open to doing all of those treatments if it's the right thing to do. We just tend to take it in an incremental approach.
Okay, gotcha. All right, great. Well, let's bring in the rest of our panel. And Angela, what I'll do is I'll take the screen back from you.
Okay.
A moment, and what I'll do is pull up. We have a good amount of time for questions, and we'll get to as many as we can. In a case that we don't, we do have some contact information here for our panelists. So I do encourage you, if we don't get to your questions, to please reach out to them, because they'll all be good resources for you for your particular questions. But I want to circle back. We heard from Charlie and Angela, their excellent presentations. We have a few other panelists that I just want to reintroduce to you and kind of give a little more sense, or ask them, I guess, to give a little more sense of their background to the audience. So Richard Nassy and Michael Frederick both have been working in their respective cities on the RRFB, the Rapid Flashing Beacon, and the Pedestrian Hybrid Beacon, or HAWK, for many, many years, and have, I think, some of the most experience of anyone in the country with these treatments. So I'd like to ask each of them, Michael first, and then Richard, to just talk briefly about you know, how far back your experience with these treatments goes in each of your cities. So Mike, would you mind starting that?
Sure, no problem. Thanks a lot. We started as the first jurisdiction in the country to experiment through permission to experiment on the rapid flashing beacons in 2006. We started with 2 locations, and the compliance went from a base yielding of less than 2% to almost 80%. So we initially increased our permission to experiment to 18 locations. So in the last 10 years, we've now reached 107 installations. And what we've done here is progressively do it through priority first because of the expenses, doing the crossings with the most exposure first, so the highest number of lanes, highest number of pedestrian crossings, and worked our way through now to we're pretty much caught up after 10 years and installing them, actually considering new crosswalk locations. Our approach has been, other than prioritizing, is uniformity. We want to make everything like it is in the MUTCD uniformly applied when we put in the RRFB. So we install a median if it's possible. We always put in the advanced stop bars, and we also include the dilemma zone line, which is the solid lane line leading up to the stop bar. And we also eliminate the lane lines and the center line between the stop bars and the crosswalk to create a safety zone. So we think a uniform approach for every crosswalk is better observed by the motorist than incremental.
Very good. Well, thanks, Mike, and thanks for being here to help answer questions. Your experience is going to be really valuable for this. And I want to turn it now to Richard. Richard, as Charlie mentioned, the Pedestrian Hybrid Beacon and Hawk, really got its start down with you and down in Tucson. Because you talk about maybe a little bit about the history there.
I'd be glad to, and thank you for inviting me to be part of this webinar. Again, the first Hawk was installed in Tucson in 2000, so there's about 17 years of experience with the Hawk, and it became part of the national manual of the MUTCD in 2009. Most of the Hawks in Tucson are on multi-lane divided highways. The majority of them in the 90% range are at intersections, and the 85th percentile on these multi-lane divided highways varies from in the range of about 35 miles per hour to over 45 miles per hour. And fortunately, even though I've been gone from the city for a while, and now with a consultant with the Pima Association of Governments, the city police have been kind enough to keep me informed as to the crash experience at the Tucson Hawks. And I'm glad to share with everyone that there's been no fatal crashes at any Hawk since the first one was installed back in 2000. I hope that continues.
Wow, that's very impressive, Richard. And hope that that's been the experience elsewhere as well, because that is great. And that certainly many years experience you have with these. And as you both mentioned, you kind of got the refuge islands and the advanced stop and yield lines kind of worked into your system as well. So that, as Charlie mentioned, these are packages of countermeasures and not necessarily just standalone pieces that you implement necessarily one at a time. So that's great to hear. And then Peter Unn and Keith Sinclair are also on the line. They're joining our panel as well. And Keith and Peter, you have the experience of I think working, I don't even know how many cities you've presented in, but kind of going through these countermeasures with individual cities through trainings and technical assistance. Peter, I would just ask maybe if you can talk a little bit about that, and I wonder, one of our first questions that I had was, clearly there are safety effects of these countermeasures that have been demonstrated through this research and other studies. From FHWA's perspective, what are you all doing to kind of promote these and push them out and make sure that they're getting into the hands of people who need them?
Great, thanks, Dan. Appreciate the question. And it's actually very timely because Keith and I are right now in Portland doing an Everyday Counts Summit, and we are promoting the STEP initiative, which stands for Safe Transportation for Every Pedestrian. And this actually fits very well with what Charlie and Angela stated, because it's at uncontrolled crossing locations. Based upon our data nationally, we're looking at over 66% of fatalities occur at non-intersection locations, and then 16% of pedestrian fatalities occur at uncontrolled intersections. And so a large number of uncontrolled locations nationally, and so STEP is focusing on promoting not just the countermeasures that Charlie talked about, but we have 6 that we've selected, and as you mentioned, and it was talked about, there are additional, but our 6 are crosswalk visibility enhancements, pedestrian refuge islands, raised crosswalks, rectangular rapid flashing beacon, pedestrian hybrid beacon, and also road diets. So those are sort of the 6 that we're promoting, but we would obviously, when we have opportunities to come and talk to you about STEP and do workshops and technical assistance, we can talk about others as well. And I really appreciate, Charlie, and the research that you guys have done just to, I think, in this area that's just growing, making things more solid with regards to the numbers and giving better data. And Angela, great presentation with regards to how you guys are using it. So the other aspect that I will say is that we will talk about policies and processes, which Angela did a great job with. So we could provide technical assistance to not just pedestrian focused cities and states, but to any state that buys into STEP. So I'll stop there, and if there's additional questions, I'll take those. They come in.
Great, thank you so much. So I wanted to lead off with a question that I'll pose to Richard and Mike first, and then I'll let everyone else kind of weigh in. But it's a question that I think we get on this topic more than any other, and it is, you know, you're looking at both the rapid flashing beacon, rectangular rapid flashing beacon, and the pedestrian hybrid beacon, often used under similar conditions. You have typically multiple lanes in a lot of cases. You have higher speeds and vehicle volumes. You tend to have a good number of pedestrian crossings. At what point people want to know, do I need to consider a pedestrian hybrid beacon as opposed to a rectangular rapid flashing beacon? Given a particular site and its characteristics, how do you make that decision? And I guess, Richard, if you want to kind of weigh in, and then Mike, will turn it over to you and go on from there.
Basically, there's quite a bit of engineering judgment there. It's the amount of activity and the speed of the vehicles and the distance they have to cross and the geometrics associated with it. We generally, on the higher speed streets and the wider streets, we go to the hawk type operation, but on some of the lower speed streets where the crossing distance isn't quite so far, we go to, the city is now using the rectangular rapid flash units. The other decision we have to look at, and the priority factors, you might see on slide 10 is what the city, and similar to what the state of Arizona uses. Now in Arizona we have a stop requirement for the school crossing. So if it's a school crossing, then we'd move probably to the concept of a hawk operation. So and again, if it's a heavy crossing with a lot of elderly people and they're moving a little bit slower, again you can see the second from the bottom, the presence of elderly or disabled pedestrians. Then we start looking at the hawk operation. But these are the things that are used by the city of Tucson, the county, and the state, and we all are doing it in a similar fashion.
I'll chime in on the RRFBs and our experience here. We started off prior to 2006 with permission to experiment with the Hawks, and didn't find it to be too successful. We had less than 80% yielding compliance to the solid red. And around that time is when we were exposed initially to the RRFB. And what we found is that there's critical mass. Just like Tucson experienced with the Hawks, more is better. The more you have, the more familiar your traffic is with it, the better recognized it is, the more compliance you get. So the problem we experienced is that once we started expanding from the initial 18, the calls coming in were for, when am I getting mine? So I think what we found is that with the uniform application and the numbers that we have in now, everyone's familiar with it in the city, and even visitors because of the exposure.
Yeah, and a good point. And I want to come back to that topic of sort of the public outreach and education side of these things and getting them kind of worked into the culture, certainly. I want to kick it to Charlie, though. A few questions, Charlie, about the CMFs that you developed in part of the study. And in particular, I guess what would be helpful, I think, is if you go back through the point you made about the combinations of treatments, CMFs for combinations of treatments versus CMFs for just a standalone piece. And how would someone know, for example, if they were to put in a refuge island with an advanced stop yield sign, would there be a CMF for that? How do you kind of tease apart these and kind of look at them in that way?
Okay, that's a real good question. So first, let me talk about the RRFB and the pedestrian hybrid beacon. As I said earlier in our presentation, most of the time that those two devices are used, independently obviously, they're used with some other treatments along with them. Usually agencies put in maybe high visibility crosswalks, also advanced yield or stop lines with signs, and oftentimes with a raised median island. So the CMF that you see in that chart, the 0.45 for the PHB and the 0.53 for the RFB, those are CMF values for any one or combination of a PHB or an RFB. In other words, you don't need to combine numbers. Just if you're going to install a PHB, do it the best way you can. Richard's, can add some flavor to about, what combinations they use in Tucson, and Mike may want to, also respond to what combinations they use in the RFB. But those CMFs relate to whatever happened to be there, at the selected treatment site. And almost in all cases, there were at least 2 or 3 treatments. Very rarely was there just a PHB alone or an RFB alone. And we actually did a CMF. If you have a pedestrian hybrid beacon combined with an advanced yield or stop line, the CMF is slightly better, but very similar to what the value is right there. Actually, we have a Transportation Research Board paper that got accepted and is going to be published early next year, and that actually gives these numbers with a little bit more detail. So I think I can say this: if anybody wants a copy of that TRB paper, if they can let Dan know about that, and I think we can send that directly to you without getting into too much trouble with TRB. But it gives a lot, more of the detail. It's about a 20-page document, so it's not nearly as detailed as the full NCHRP report. Mm-hmm. But so, I would say use the numbers in the table there. And did I respond to the other question about how these compare with previous CMFs?
Yeah. So let me lead into that one a little bit. There are many more pedestrian safety countermeasures than just these 4, right? We have a lot of different treatments. We did a whole 12-part series last year focusing on individual treatments. Each of them, some of them have crash modification factors established through research, some do not. Can you tell us, Charlie, for the ones that you looked at in this study, did any of them already have crash modification factors established, and which ones of these are new, sort of brand new crash modification?
Okay, the answer is really only one of them had what I'd call a defendable CMF. There was no CMF for advanced yield or stop lines with signs. There was no CMF in the literature on RRFBs. So these are brand new. These are the only ones that we've seen and we developed with a fairly large sample. In terms of refuge islands, there's really nothing, I would say, very defensible that's been done in the last 20 or 30 years that would be a very good CMF for refuge islands. So I would say certainly I'd recommend using our CMF there for refuge islands. Now for the pedestrian hybrid beacon, there was a fairly good study done by CTI 4 or 5 years ago that came up with a CMF that was not too much different than ours. It was slightly better. The CMF was a slightly lower value. I think they found about a 60% reduction, or about a 0.4 CMF. So it's very, very similar to ours. And the only difference is ours did include more cities and more sites than they did in that study, and it's a little bit more recent. So it's very similar, though. So I would just say recommend using our values. And one thing I will add is, even though we wanted in advance of the study to be able to separate out CMFs by number of lanes, by intersection or midblock, we didn't have enough sites with enough variety of those site conditions to be able to do that. So these would pretty much apply to any ADT or number of lanes, et cetera, that we had in our study.
Okay, very good. Thanks, Charlie.
Go ahead, Richard. Charlie's absolutely right. I concur with him, but I also want to call the listeners' attention to NCHRP Report 600, which was released last year, and basically the Hawk signal beacon had a 99% driver compliance rate with the signals. So that's something else that the listeners can view and consider if they go to the NCHRP Report 600, page 15-4.
So that's a good point, Richard, and it brings up the topic of compliance with the treatment. And Charlie's, it's important, I think, to recognize the fact that Charlie's study looked at the reduction of crashes experienced at a site, but it did not necessarily look at compliance. You didn't look at things like basically yielding rates. And I know Mike and Richard, you've both looked at changes in compliance or yielding rates for your various treatments, and I think maybe you tossed out some numbers, but maybe Mike, I'll start with you. Do you have a sense overall of when you start installing, you've done enough now where you know that when you put a rapid flashing beacon at a particular site, you can probably kind of guess what, based on your experience, what the compliance will be, improvement of compliance will be. Can you share that with us, or any figures you would toss out there?
Sure. When we first started with the 18 locations, the average compliance over 180 days was in the high 70s. We followed up that with police enforcement details at those locations, simultaneously adding 30 more locations. And from there, the compliance went up to the high 80s, and with additional locations that we're up to now at 107, we're getting very high 90% yielding compliance. And that's measured with the first vehicle in the platoon. So as you step out and conduct your study into the roadway, you're monitoring that first vehicle as it approaches, and it's outside the dilemma zone. So high 90s in St. Petersburg with that. And what we found as well is that we virtually get 100% compliance. Sometimes through the flash cycle, you get everybody to yield or stop.
Very good. And Richard, what about you all? I mean, I think you may have mentioned some information about compliance with the Hawk or PHB. Anything you can add to that? What your experience has been?
Certainly, again, that was part of the NCHRP Report 600. Basically, many of the Hawks were at locations where we had an activated overhead flashing amber beacon, and that was then replaced with the Hawk signal. So the average driver compliance rate went from about 49%, which was reported in NCHRP, to again the Hawk has the 99% compliance rate average. Some are 100, some are a little bit low, but 99% is pretty good when you have a lot of little tykes crossing the road.
Very good. And I want to now turn to Angela. Angela and Charlotte, I'll first ask, do you have a sense of what your compliance rates are at some of the locations where you've installed the pedestrian hybrid beacons? And then the second part of that question is something we haven't really gotten to yet, is how do you all view the role of a sort of a broader education and enforcement effort to kind of go along with some of these changes to really reinforce, like Mike mentioned, they've done some enforcement at their site. Do you all see that as part of your package moving forward?
So from a compliance rate perspective, someone mentioned it, I'm not sure which of the other gentlemen on the call mentioned it, but there's definitely strength in numbers, so to speak. When we only had 3 pedestrian hybrid beacons in the city, and now we're upwards of, I want to say we have 15 or so installed. We're definitely seeing much better compliance because our drivers are just more familiar with it. Really the challenge is that they're just not familiar with the fact that they're supposed to proceed on the wigwag red when it's clear. So that plays into that a little bit, that they're almost too compliant, if you will. But compliance has definitely gone up. I don't think that we've done any rigorous studies on it. It's just been strictly, observations in the field and observations by staff at various PED hybrid beacons that we've put up around the city. Tell me again the second part of your question, Dan. I'm sorry.
It's not exactly related to the first part. It's more on the question of, you can do so much with the design piece of it, but at a certain point to really get that compliance rate and then hopefully the crash reduction rate, to the next level is maybe done through some enforcement activity to really hammer home the point and get that yielding rate up. So I don't know if you all are thinking about that as you said you're thinking or you're looking towards some rectangular rapid flashing beacons and other locations where you're making improvements. Do you foresee a role for that enforcement activity to kind of further emphasize the law and really try to improve yielding rates in that way?
We haven't utilized the enforcement activity very much. We've done some education in regards to the pedestrian hybrid beacon a couple different times. In fact, I think we're up to 3 times now over the last 4 to 5 years. We've done utility mailers. Believe it or not, we still have people who get their utility bills in hard copy. And so we've done utility mailers trying to explain to both the motorists how they're supposed to behave at a hybrid beacon, as well as the pedestrian, how the pedestrian is supposed to utilize the hybrid beacon. And we have not done much of the way in enforcement at pedestrian hybrid beacons. We will be looking for probably our CMPD counterparts to do some enforcement, in particular at one location where we are looking to install the rectangular rapid flashing beacon, just because the installation is in specific response to extremely poor driver yielding behavior. So we intend to have CMPD conduct some enforcement events there around the Watch for Me NC campaign.
Okay, very good. Yeah, I think that sounds like a great approach, and it sounds like it's done well in the other locations that we've mentioned. I want to shift gears. We don't have a ton of time. I want to get through as many of some of these other ones as we can. One issue that people often bring up about the push button activated treatment, the rapid flashing beacon and the Hawk or the PHB, is that it does require a pedestrian push button activation. And in some cases, I know when you first install these, the rates that pedestrians will use the button and push the button can be low. So in those sorts of cases where agencies may be seeing low rates of push button usage, Mike and Richard, maybe I'll start with you. What options exist for a different type of activation, such as something like a passive detection? Have you experienced with this at all?
Yes, we've looked at this passive detection with cameras, and again, we're finding that some very interesting elements. We also found out when TTI finished their study of hawks throughout the nation, basically we had a 91% pedestrian compliance with the push button. What we found out, it really wasn't an activity of an engineering sort of thing, but a psychological thing, because we used to put our hawks into a synchronization pattern, and when the pedestrian pushed the button and waited but saw a gap, they would take that natural gap and cross, and then after the cycle was finished and we're getting ready to go into the synchronization pattern, the drivers are stopped but the pedestrian was gone. So we've changed that operation to a hot button or a demand only button, and we found that we get extremely high pedestrian compliance. They do press the button and the drivers do stop and they can see the pedestrian cross, and then they proceed when the crosswalk is clear during the flashing red. It gets better behavior from both the drivers and pedestrians if we don't have a long delay before we service the pedestrian. Also, in those areas where we have usually elderly or handicapped, we've been experimenting with basically camera sensors to pick up the presence of the pedestrian, and that worked fairly well, except in Arizona when the temperature gets up to 110 and there are no trees on the crossing. we find that the pedestrian will move into the detection zone and look for a button or press the button and then move away from the detection area at the corner and go under the shade of the nearest tree, which could be maybe 20, 25 feet away. And that fooled the camera. So we basically went back to the push button operation because of the high temperature and sun in the summer here.
That's an interesting issue that I would not have thought of with the shade issue. Mike, any passive detection you all are doing with your rectangular rapid flashing beacons, or any experience with that?
Yeah, we decided from the onset that we did not want to do passive detection. We wanted the pedestrian engaged from the start. So our initial units actually had an infrared detector that would detect the presence of the pedestrian approaching and activate an audio that would tell them to push the red button to cross the street and activate the beacon. That worked well at the start to get people engaged that there was something new there. From there, we went with the static signs that says push the red button to activate the beacons. And it worked really well, because what pedestrians found is that this would actually stop cars, to the point that I was just out looking at one of those locations one day, just standing next to it, and some pedestrian came up to me and said, no, you got to push the button. That makes it work. Cars stop. So we found that it's worked fine without passive detection.
Yeah. No,
Dan, if I might add one more piece on the passive detection.
Please.
If you go to slide number 14, we found passive detection does have a role to play, and that is when we have a lot of elderly or people in walkers crossing the highway. Once they press the button and they get the pedestrian device, it's the last slide. Yeah, I think you're there right now. We have passive detection that can sense the presence of the pedestrian in the crosswalk. And you'll see the sensor is in the top left corner there. It can tell if the pedestrian's there, it can tell if they're still moving in the crosswalk, and that automatically tells the hawk indications to stay red, extra time for the pedestrian that needs extra time. So that's where we're using our passive detection.
Okay. And this is somewhat related. We're talking about the push buttons and the detection. Obviously, we need to be considering and including in all of these cases accessibility considerations for those who may be blind, may need other treatments. So let me ask you, many people on the line may be familiar with accessible pedestrian signals that you would find at signalized intersections where there is audio indications or vibrotactile indications when the signal is caught, or when the walk signal is on. Can you both speak about your experience with including sort of APS style or accessibility features within your rapid flash beacons and your pedestrian hybrid beacons? And maybe Richard, we'll start with you in Tucson.
Oh, certainly. All the new Hawks are being equipped with APS devices so that the people with disabilities can use them easily and efficiently. And all the pedestrian signals are the countdown device.
Okay. And Mike, any sort of features within the RRFB push buttons to assist that, with the audio signaling, or anything to help someone understand when the push button's gone off?
Yes, all of our crosswalks include an audible message that tells them to wait for traffic before you cross and how to cross the road. And at some locations where we've worked with the disabled community, we've actually installed a pressure pad for a woman that crosses routinely in a wheelchair that can't raise her arm to reach the button. So we put in a pressure pad at that location, and we'll make whatever modifications are needed.
That's very good. Thank you. And obviously with all of these, we didn't have a whole lot of time to get into all these other factors with crosswalk design, and especially making sure that you've got your things lined up correctly, and all the other accessibility concerns, truncated domes, all that. So that is an issue that you must consider. We just it wasn't exactly included in this webinar, but I would encourage you to make sure that if you are doing these, you have to comply with these other requirements as well, and there's a lot of good guidance out there for that. I have time for just one more question that I wanted to ask Charlie. So Charlie just completed a study of crash modification factors for some pedestrian countermeasures, and there are other countermeasures that also have crash modification factors established through research. So I'm going to ask Charlie his expert opinion on what treatments or countermeasures that are out there that still need good research to help establish crash modification factors, in your opinion, Charlie.
Okay. Well, at uncontrolled locations, I mean, there are a number of them. I'll just mention a couple of geometric measures, curve extensions and turn radii. Those are two things that we don't really have CMFs for. Also, on well, raised pedestrian crossings, that's another one that we need a CMF. There's some other things like the signs in the street, that are put in the median that say, stop, state laws, stop here for pedestrians. States like Pennsylvania that use hundreds and hundreds of those things, and some other cities do. And those are typically used more on the 2-lane or 3-lane streets. I'd be a little nervous about using those on the high-speed multi-lane roads, but we could use a good CMF for that. And there are a few others that could be looked at. And I will refer you to, if you want to see sort of one compilation of CMFs for pedestrian-related treatments, maybe Dan can put this out, but we do have a document we did for Federal Highway a few years ago, I think 2013, that goes along with the PedSafe document. But it does have summaries of several dozen pedestrian treatments and their CMFs based on sort of the best research that we know of.
Great. Thank you, Charlie, for that. And we're a little past our end time here. I have a couple things that I want to mention to you all before we sign off. That is all the time we have for discussion. But I do want to remind you that you will be receiving an email later today that will contain two things. One will be a link to the website where you can download the slides from today's presentation, so you can refer back to some of the information that was shared. That email is also going to contain a link for you to download your certificate of attendance for the webinar. So be sure to pass that around to your colleagues who are joining the webinar with you. The third thing is, after you close out the webinar, there will be a brief survey. We would very much appreciate your thoughts and your feedback on our webinar today, if you can take a moment to fill that out. And then lastly, I just want to say thank you again to Charlie Zagier and Angela Berry for delivering the presentations today. And a special thanks also to Richard Nassy, Michael Frederick, Peter Unn, and Keith Sinclair for participating in the discussion. And then finally, just thanks to you all very much for attending today's webinar. We hope to see you on the next one, and I hope everybody has a great day. Thank you.